Welcome to today's webcast. Please note today's call is being recorded. And now, to begin the program, I'd like to introduce Mr. Chris Black. Please go ahead, sir.
Hey, thank you so much, Holly, and welcome everybody in our audience to today's webcast, Replication Over the WAN, an in-depth guide to Veeam Backup and Replication for Disaster Recovery, sponsored by Veeam. I'm Chris Black with Redmond Magazine, and I'm going to be your moderator for today's event, so thank you all for joining us for today's webcast. Just a few quick things before we introduce today's speaker and he gets started with today's webcast. We will have a Q&A at the end of today's webcast. However, please feel free at any time to enter your question in the Ask a Question box on the left-hand side of your console. And hopefully, if time permits, we'll get to everybody's questions and supply some answers. Also, this webcast is being recorded and archived for future viewing and listening purposes, and we'll send you a link to the email you registered with within 24 to 48 hours after today's webcast. Joining us for today's webcast, we have a really great presenter, a good pal of mine. His name is Chris Henley. He is a Microsoft IT professional and evangelist at Veeam. He's focused on technologies related to Windows Server and Hyper-V. He is a published author and regular speaker and presenter at user groups and at major technology conferences around the world. He's really fun. He's really energetic, and his style of communication, he has a way of making technical concepts easy to understand, even for folks like me. And he just is an all-around good guy. He loves talking about technology. And without further ado, I'm going to introduce Chris so he can speak to you all. So, Chris, why don't you take the floor?
Hey, Chris, thank you very much. And thanks for the nice intro. Well, that's very kind of you. Well, today we're here to talk to you about specifically a topic that is near and dear to my heart, and it's a topic called replication. And we're going to tailor that specifically to a discussion around replication that occurs over a wide area network linkage. And we're going to talk to you about some basics of replication and then some specific details around how you might custom tune that replication that's occurring over a wide area network so that you maximize the replication in your network environment. Now, from a background perspective, you've got to know that I am a Microsoft professional, as Chris introduced me. I've worked with Microsoft for several years, in fact 9 of them, prior to coming to Veeam. I love working with Hyper-V. I love working with virtualization. And that's become kind of my core focus. So nice logical, I guess, transition working with Veeam software for me. There's a product that Veeam makes called Veeam Backup and Replication. And for those of you that are thinking, why is not Veeam Backup and Restoration? Well, we do restoration, of course, with our backup tools, but backup and replication really are the focus of those products because we want to make sure that your recovery point objectives and your recovery time objectives, which from now on we're simply going to call RPO and RTO, are as low as they can possibly be. Now, let's go ahead and we'll move to the basics of replication. We'll kind of start from there and build our way up. Now, when we talk about a virtual environment, we're all used to virtual machines running in different types of virtual environments, like they might run standalone, or they might run in a cluster, the goal of that cluster being to provide high availability and a lack of downtime. They might also run in a third environment, which we're going to talk about today, called a replicated environment. Now, in a replicated environment, it's not exactly a cluster because we're not using shared storage. In fact, we are on purpose using different stores and different hosts to run those virtual machines, but we are providing a synchronization of content between those virtual machines on what we'll call the source host and the target host. Now, for the purpose of today's discussion, I'm going to use Hyper-V hosts as our example, but please note you can do exactly the same thing in a VMware environment if you happen to be running VMware virtual machines. When we talk about this concept of replication, the reason that replication is commonly recommended for critical VMs, which we're going to call Tier 1 application VMs, is we really want to have a close to zero recovery time objective. The closer to zero we get, the better. Now, if we think about traditional virtual machines, ones that we're backing up on a daily basis, unfortunately, because we only have a backup that is 24 hours old, our recovery time objective and our recovery point objectives are going to be relatively slow. We're going to measure them in terms of hours for RTO, and unfortunately we're going to measure in terms of days or RPO. It's too high. We really need to find a way that allows us to run our Tier 1 applications in virtual machines and be able to recover those virtual machines in the event of a loss in a matter of minutes. I'd like to see it even measured in a matter of seconds. Generally speaking, we measure RTO times on replication in intervals down around, say, 5 minutes in length, which is still fantastic. When we talk about replication, I suppose it's appropriate for us to begin with how replication actually works. If you use Veeam Backup and Replication, the process is really pretty simple. We're going to start with something called your source Hyper-V host. And that source Hyper-V host is where you're going to be running your virtual machine. Now that's the original VM, which we're going to call the source VM. Now we're going to build a replica, and so we're going to need a target location to store that replica. Now the term replica is just that, an exact copy of the virtual machine. We're going to place it at a different target. So we'll call it a target Hyper-V host. And in this example, what we'll do is we'll simply make a duplicate copy of that virtual machine. We'll use something called a change block tracking driver, which we'll talk more about here in just a second. And we will use LAN or WAN connectivity to make an exact duplicate of that virtual machine and then store it on our target host. Now, let's go back to change block tracking. Veeam uses something called a change block tracking mechanism, which in this case actually runs as a driver on the Hyper-V host machine. That driver monitors what changes occur on the virtual machine and stores them in a change block tracking file called a .cbt file. Now, when it's time for us to replicate the changes from the virtual machine on the source Hyper-V host to the target Hyper-V host, we'll take the information in the form of an incremental update. Just like we're doing a standard increment for a backup, we'll take that increment, which is actually built really, really fast because of our change block tracking driver. We already know the changes, so I don't have to go and parse the VM to look for them. I just take what's in the CBT file, add them as the increment. Increment completes very quickly, and now I pass that increment across that LAN or WAN connection, and I inject them into the virtual machine. Now when I say I inject them into the virtual machine, there is the possibility that I might want to roll back on my replica. And so we add something called a .vrb file, and we keep the changes that were actually originally there in the VM before the increment was injected. By doing that, I actually build myself a set of restore points. That's the .vrb files that you see there. So that should I want to move to using my replica on my target Hyper-V host, I also have a series of restore points that I can move back to, which actually really makes good sense if you think about it, because oftentimes if there is a failure on the source, I don't want to move to exactly the same operating set that I had on the source if that's what was the cause of the problem. Oftentimes I want to roll to a previous restore point where I know it was a good configuration, and I want to root from there. So the basics of replication really come from change block tracking, incremental updates to backup files, and then a synchronization of those increments across to LAN or WAN link to a target Hyper-V host. Now, there's more detail, and we certainly want you to go and get more detail about replication. But from a basics perspective, that's a great kind of primer on how replication works with Veeam Backup and Replication. Let's go ahead and let's add increment number 2, and as that duplicates or replicates across our LAN or WAN link, we start to run ourselves into a series of questions. How often do I do my incremental updates? Well, with Veeam Backup and Replication, those incremental updates can actually be scheduled to run as frequently as you want. Now, there is a caveat to that. We're going to let you take that time for replication down to every 5 minutes. So you can really go with a pretty frequent replication, every 5 minutes. Generally speaking, we're going to find what works best for our environment. Every day, every 24 hours, a little bit too long, doesn't really accomplish what I'm looking for replication. But somewhere between 5 minutes and 24 hours, we're going to find a time that works well for our network environment, and especially it works well for our LAN and WAN connectivity. Now, if we have high-speed LAN connections between our source and our target Hyper-V hosts, we may want to use every 5 minutes because we're not significantly concerned about bandwidth allocation or bandwidth usage on that LAN. Now, if it's a WAN link, and that WAN link already has a fair amount of traffic, we may want to actually throttle that communication. We may want to take that schedule back, and we may want to only do up to once an hour, for example. Now, there is no right or wrong way to do this, and there is no single recommendation. What I will recommend is you take your network environment, you take the links that you have, and then you decide what's going to work best. Now, let me give you a couple of quick pointers. I said we were going to go into detail about how Veeam Backup and Replication will maximize the use of your WAN links. So let me give you some insights into what you get in terms of benefits in replication with Veeam Backup and Replication. One of the things that we do is that we make certain that all of the increments that are passed across that WAN link are actually sent in a compressed format. And so we actually do a compression. We use a compression algorithm on the source Hyper-V host. We compress those increments before we send them across the WAN to save you a fairly large chunk of disk space. Now, when you're building these replicas, you're actually going to structure them in various architectures based on your corporate needs. Let's talk about the different architectures, and let's talk about the files that we're going to use as part of that replica. When we think about replicas and replication, let's talk the files first. Each replica is going to consist of the full virtual machine replica, which includes the virtual machine configuration files and the virtual disks. So you will need to make a complete copy of the virtual machine, and that complete copy is going to need to reside on both the source and the target host. You'll also use replica rollback files, which are your VRB files, your restore points, and you're going to have some replica metadata in the form of .vbk files that we use to store replica change IDs. So there's a little bit of file traffic that's going to be passed, but you can see the bulk of that file traffic is actually going to come at the initial setup of the replica. You can see that's where I'm going to get my full copy. All the configuration files and virtual disks are going to come at that point in time. And I've got some good ideas that will help you to minimize the WAN traffic when you're making that initial replica configuration. About more of those here in just a few minutes. Let's chat about architecture and throw some additional terms at you. When we talk about architecture from a replication perspective, we refer to a couple of different components. I've been talking to you about a source Hyper-V host and a target Hyper-V host. And that architecture would be, I suppose, the simplest configuration that you could actually use in conjunction with building a replica. Now, there are also some additional components that we need to talk about. There's something called a backup proxy, which can be used in an architecture for replication. And there's also something called a Veeam agent that we'll use in conjunction with replication. Now, how you structure those components, the source, the target, the agent, and the proxy, determine what we use for terminology for how we describe that replication architecture. Let's move and let's talk about a basic one here. This is called on-host replication. And in this case, you can see that on-host has reference to where we place the source-side agent. So in this case, the source-side agent, which is going to perform the functions associated with increments, updates, synchronization, compression, throttling, all of those activities are going to happen with that agent. That source-side agent is going to run on the source Hyper-V host. The target-side agent will run on the target Hyper-V host, and we will call that on-host replication. Now, if we were to move that source-side agent, because unfortunately the source-side agent does add some workload to the Hyper-V host, and if we want that Hyper-V host just to run the virtual machines unimpeded, no extra workload, we're going to have to find a different solution than on-host replication. If we want that, the way that we would go about it would be very much the same as what we would do in a backup scenario. We would add our proxy, in this case a backup proxy, and we would move the source side agent to the backup proxy. Now the workload that's associated with that copy, compression, transmission is all handled by the backup proxy instead of by the source Hyper-V host. And the source side agent will actually manage that communication between backup proxy and target Hyper-V host. When we use this style of architecture, we call that off-host replication, because we place the source side agent off the Hyper-V host or off the VMware host if you were using this in a VMware environment. The benefits are obvious. I get less overhead workload on my source Hyper-V host, and the backup proxy, which has been designed to handle proxy workloads, can now handle that workload, and I get better control, better opportunity as far as communication across that LAN and WAN without impacting my source side Hyper-V host environment. Easy on-host replication, agent runs on the Hyper-V host. Off-host replication, agent runs on the backup proxy. Let's talk about replica seeding, because after all, we said the most difficult problem associated with LAN-WAN communication in building a replica was the fact that the initial virtual machine has to have a complete copy transferred across a LAN or a WAN link to our target Hyper-V host. And that just frankly is going to probably have a significant impact on any WAN link that we might have in place today. When we think about virtual machines, not uncommon for us to find virtual machines up to and approaching 10 gigabytes or more in size. If I'm going to build a replica and then transfer that replica virtual machine across a WAN link, none of us want to transfer 10 gigs across WAN links if we can help it. There is a better way. You could use something called replica seeding. And in replica seeding, what we do is we simply make a VM backup of the virtual machine. So we'll use Veeam Backup and Replication. We'll make an active full backup of that source virtual machine, and we'll put that on removable media. I like it on one of those portable USB drive devices. If it happens to be SSD-based, even better, right? Now that I've got it on portable media, I can physically transport it from the source Hyper-V host location to the target Hyper-V host location and then restore it from backup. If I've got a LAN connection, I could transfer that large virtual machine across the LAN. And of course I have an option, but I could transfer that VM backup across the WAN if I had no other option. But with replica seeding, we're saying let's take the VM backup, put it on portable storage, use that portable storage to move it over to our target Hyper-V host. We'll restore from there. Now this time I'm not using my LAN or my WAN connectivity. I'll restore the VM backup once I get it on my target Hyper-V host. Then I'll establish the connectivity between the source and the target. Now this way I didn't impact my WAN link. I still am going to run through the traditional exercise of replicating increments, but the increments can be easily controlled as they're passed across that LAN or WAN link. Now for those of you that are thinking, hey, what if I already have virtual machines running on my target Hyper-V host environment as backups? Well, great. Now all you need to do is provide a mapping for the replication between the machine that's running on the source Hyper-V host and the one that's running on the target Hyper-V host. So replica mapping, similar I guess in a way to replica seeding, although in this case I don't have to go through the process of making the backup, moving it to the target, then restoring it on the target, because I already have the virtual machines. I simply need to map a connection, a replica map, between the source Hyper-V host virtual machine and the target Hyper-V host virtual machine. Once that's done, now I can use change block tracking, add increments, and synchronize those virtual machines as updates occur. Again, dramatically less impact on that WAN connection, and I still get the ability to use replica. just like in our previous example, I still run increments. They still come across the WAN. Replica Mapping as a replication tool runs exactly like the example that I showed you at the beginning of the webcast. So we still create VRB restore points, and those restore points are used to provide us with opportunities or access to back to a specific point in time and run the virtual machine from that point in time. You know, there's more to replication than simply getting the virtual machine and the synchronization, the increment synchronization, from the source Hyper-V host to the target Hyper-V host. In almost all of our network environments, we actually run different network configurations in our source network and our target networks. And we need to be able to have a way to automatically map operations, specifically network addressing and other network resources, so that the virtual machine will operate effectively, even though its replica happens to be going to a different network. And the thing that we use to maximize that is something called network mapping. Now with network mapping, we're going to configure something called a network mapping table, and that network mapping table is going to contain, among other things, the network and the IP schemes in both the production or the source network and the DR or target network site. Now, in a common case, you would actually need to change the network configuration of the VM replica before you started it. And we really don't want that to happen because it really adds another ugly manual process. And we want to eliminate that, and so we use a network mapping table to do that. In this case, the network mapping table is used by the replicated VM. It will use the same network configuration as the original VM if it's in the source network site. Now, if the network is in our DR site, it doesn't match our source network, we'll transition and we will use the information in the table to run the network settings for the DR site or for the target network. The network settings for a VM replica, by using the network mapping table, are always kept up to date with the DR site requirements and with the source network. That way, in case you choose to fail over to your VM network, it's always going to connect to the correct network environment and be operational. So network mapping table, really important, something that we really don't want to miss, especially in this type of discussion. Now, for those of you that are scratching your head and you're saying to yourself, hey, I love the idea that I can do replica seeding, that make a backup, physically move it over instead of running it across my network. Great idea. Glad we addressed the concept of different networks. However, each of these networks will likely demand that I change the IP address, default gateway, subnet mask, DNS address, and other network services that are going to be provided to the individual virtual machine. How does that work? Well, that's really a good question, and the way that it works is through the use of something called a ReIP process. Now, for Windows-based virtual machines, Veeam Backup and Replication will automate the reconfiguration of the virtual machine IP address. So if the IP addressing scheme in the source site is different from the target DR site, you can simply create a number of ReIP rules for each replication job that you set up. That way, when you fail over to your replica on your target DR site, Veeam Backup and Replication will check if any of the specific ReIP rules apply to the replica. And if the rule applies, then Backup and Replication console will actually mount the image-based disk of a replica and then change its IP address configuration in the Windows registry. Now, I know you're thinking, gosh, that's got to take a long time. Actually, it doesn't. It takes less than a second. So if you make that transfer, if you do fail over from your source to your target DR site, Backup and Replication will check, validate the network, match it to, validate your rules, match it to the appropriate site, in this case our target DR site, change the addressing scheme in the Windows registry, and we're online. So rapid change, ReIP is what it's called, and you do this by making a set of ReIP rules. Now I know you're thinking to yourself, what happens if I fail back? What if I go back to my source site? Well, remember when we make the transfer from target to source or source to target, we're going to validate the ReIP rules. And so if we undo failover for any reason, it will simply fail back to its original location. The replica IP address gets changed back to the pre-failover state, and everything runs just like it's supposed to on our source site, which is really kind of cool. So failover and failback with ReIP rules automates the process of IP address assignment and really makes that process of translation, I guess, which is probably the right term, from source site to DR site quite easy. Let's talk about this idea of failover and failback for a few minutes, because I want to make sure that you clearly understand what it is that you have as options with failover and failback and how that might impact LAN and WAN connectivity. On the slides in front of you, you can see a source and a target Hyper-V host. This has a running replication relationship already built, and the virtual machines are being replicated. You can see that VRB file sitting off to the side of our target Hyper-V host, so it looks like I've got increments and synchronization occurring. Now, in the event that something goes wrong and we decide we want to initiate failover, meaning I want the target Hyper-V host virtual machine to take over, first thing that you want to know is that this is a manually kicked off process. This is something you're going to turn on. This is not something that we automate like we do failover on a cluster in high availability. Even though we use the same term, failover, it is not an automated process. I want to reiterate that to you. Especially when we start thinking about our WAN connectivity, we really want to limit false failover or unnecessary failover, and one of the ways we do that is by making sure that it only occurs via manual kickoff. So you're going to go and kick off this failover process. When you do, we're going to say, all right, let's take this prior addition increment. We'll use that increment as the starting point for our virtual machine. We're going to make a snapshot of that virtual machine, and we're going to hold any changes. That's why it's got that nice little red box around it. We're also going to go to the source Hyper-V host, and we're going to say, hey, we've initiated failover. I want to stop on all future replication to this virtual machine. And then we'll run the virtual machine from the snapshot that we've made. We change the state of the replica. Remember, the replica is on source and target. It's the channel that provides opportunities for updates between them. We'll put that to failover as its state. And it will run as long as we choose in that failover state with changes being written to the snapshot. Make sense? So when we talk about failover, what we're talking about is a stoppage to the replication partnership, a freezing of the VM on the target Hyper-V host, because after all, we don't want it to be changing, and we want to run everything from a snapshot. Now, once I make failover, what are my options from there? Well, I actually have three different options. I can make failover permanent, which is exactly what you would think. We want the target Hyper-V host to simply take over that virtual machine and run it from now on. I can do what's called undo failover, and I can do what's called failback. And we probably ought to talk about the difference between each of those three. So without further ado, let's do just that. Let's talk about making failover permanent first. Permanent failover is really nothing more than making the process of the failover that we've already performed permanent for the long term. Now, when we talk about permanent failover, let's go ahead and show it to you. What we will do is take the snapshot with all of its changes and incorporate that into the virtual machine. Notice we remove the hold. Next, we will eliminate and exclude the VM relationship between the source host and the target host. We want to do that because, remember, the target Hyper-V host is now the permanent holder of that relationship. Now, in the future, we could go back and we could say, gosh, I want to make a new replica. I want to take this virtual machine that happens to be on my target Hyper-V host, and I want to make a replica of him, and I'm going to put that replica over on the source Hyper-V host. Now, strangely enough, we would change the terminology, right? The virtual machine that is running in permanent failover is no longer on the target Hyper-V host. The target has become the source, and the source would become the new target. So we would reverse the roles. It is important to note that when you perform permanent failover, the original replica relationship, that virtual machine will be excluded from any future updates, incremental updates from the source to the target Hyper-V host. What if you don't want to make the failover permanent? What if I want to be able to go back to the way things were? Let's talk about the idea of undo failover, because that's kind of a cool concept. When we talk about undoing failover, let's say that for whatever reason, the source Hyper-V host happened to lose this virtual machine. Maybe we lost connectivity. Maybe the cleaning crew was working on the server room, and somebody accidentally unhooked one of the switches, routers, or hubs that connects this source Hyper-V host to the rest of the world. And we didn't lose anything from a virtual machine perspective. We didn't lose anything from a hardware perspective. We just lost connectivity, and so we failed over to make sure that the workload was still serviced. I could just undo the failover that has occurred once my source Hyper-V host is plugged back into the network. I could go through this process where I take the snapshot and simply delete it. I remove the hold from the virtual machine on the target, and I remove the stop from incremental updates from the source. Essentially, I have just done exactly what the title suggests by undoing my failover. Now, please keep in mind, if you undo your failover, I deleted the snapshot. So any changes that were made during the process of failover are no longer going to be a part of that virtual machine. So when we talk about undoing failover, we are literally going back to the way things were before failover occurred. So if you have data that has been established or created during that time frame, undo failover may not be your best option. You may want to consider something else. What other options are there? Well, we said that we could do what's called failback. Now, in a failback environment, we're going to run the opposite. Let's talk about failback here for just a second. In a failback environment, Veeam Backup and Replication will actually streamline and automate your disaster recovery with its failback capabilities. Now, failback is really just the process of switching from the VM replica to the production VM. During the failback process, Veeam Backup and Replication will use the working replica to recover the original VM and then switch back to it. So if you manage to restore operation of a source host, you can switch back to the original VM on the source host. However, if the source host isn't available, you could also restore the original VM to a new location and switch back to that. So when we start thinking about this idea of failing back, it could be to the original VM in the original location, or it could be somewhere else. So you could use failback the VM to the original location, to a restored upfront from backup to a new location. You could fail back to an entirely new location by transferring all of the replica files, if you wanted, to your selected destination. Now, we're talking about WAN and protecting WAN traffic and limiting WAN traffic. So ideally, we want to limit the amount of stuff that's going across that WAN, so failing back to the original host is probably our desire. Now, when we fail back to the original host, we're going to stop replication, and we're going to make what's called a failback snapshot. At that point, we'll use our LAN or WAN connectivity, and we will make sure that data is synchronized back to that initial host. Let's talk about undoing failback. So it is actually sometimes desirable to move from a situation where we've done failback and we want to undo it and go back to the way that things were with failover. I know that that sounds a little complicated, but it's not uncommon to see this occur. Now, remember we're at stop. everything on the target Hyper-V host is in hold, and we're running on the source Hyper-V host in this failback mode. If I want to undo failback, I'll remove the stop from the target Hyper-V host. I'll remove the failback snapshot. Then I'll remove the hold on the failover snapshot. And I put the stop back on the source Hyper-V side. Now I'm running in failover mode again. Now, just like when we undid failover, remember all of the changes associated with those snapshots were removed. And so when we undo failback, the failback snapshot is removed, and any changes that might have been made during failback are also removed. So please keep in mind, if you have a workload that is initiating a lot of changes, undoing options generally are not the ones that we want to choose because we want to preserve the data. If you're in a workload environment where there is not a significant amount of change that is occurring, then an option associated with undoing failover or undoing failback may be one that you prefer to choose. Lots and lots of different options there. Last but not least, we definitely need to talk about the idea of committing failback. Now, if we have failed back to our original source virtual machine, and I want to keep all of that data, right? This is not undoing failback. I want to keep all of the data that's been made, and I want to go back to the process of sending my replica updates or increments every 5 minutes from my source Hyper-V host to my target Hyper-V host. I need to make sure that I keep the data in the failback snapshot and the failover snapshot and my increments. So what we do is we simply remove the stop, we consolidate, well, remove the stops each place, consolidate the failback snapshot, and consolidate the failover snapshot into the target Hyper-V host. At that point, we will change the state of the replica back to its normal state, and we will continue the operation of creating increments and then synchronizing those increments across that LAN or WAN connection to our target Hyper-V host environment and creating additional VRBs or restore points, just like we had in the original environment. Now, when you think about using replication in a WAN-based environment, we've talked at length about some cool techniques that you can use: Replica Seeding, Replica Mapping, the use of network mapping, ReIPing, considerations for the way we would execute failovers versus failback, and committing those changes or transactions. Think about what's going on in your replication environment, and think about how it relates to the WAN connections and the LAN connections that you're using. If you'll do that, I'm fairly confident that you're going to have a great experience with replication, and that experience will easily fit into the LAN and WAN requirements that your network happens to be under in today's network world. With that said, let me give you a series of resources. We'll call this my call to action slide. First thing first, if you haven't worked with Veeam Backup and Replication, go out and get the free trial. The trial is available. You can get it here. I put the Hyper-V server link. You're welcome to download it for VMware. In fact, currently Veeam uses Veeam Backup and Replication version 6.1. It will work the same on both Hyper-V and VMware environments. There's some additional webinars that are out there for more detail around backup and replication topics. If you want to know more about the backup and backup tools, please go out, use those resources. Read the VM Backup and Replication User Guide. That resource is one of the best resources that I know of about Veeam Backup and Replication. Use that link. You can also, of course, follow us on Twitter. I'm at Nerdy Like That. Rick Vanover, my coworker, at Rick Vanover. We also have the @Veeam and the @HyperVBear Twitter tags. We constantly seem to be talking about taking questions and responding to questions about Veeam Backup and Replication and what an amazing tool it is. Now, two things more that I want to throw into this discussion that isn't included on this particular slide. First, recently, 5 weeks ago, I guess, Veeam announced that there is a free edition. Now, this is not a free trial. There is a backup free edition, which includes a tool called WinZip. And for those of you who've used WinZip in the past, you know WinZip takes a a set of files and builds a compressed archive of those files, VeeamZip will take a virtual machine, associated virtual machine files, while the virtual machine is running, and make you a compressed archive that you can store on a USB stick or other portable device, and it'll do it while the machine is running. Really kind of cool. So there is a free edition of Veeam Backup out there as well. Now please note the free edition does not do replication, so especially based on today's webcast, I'm assuming your interest would be in replication. At that point you'd want the free trial, not the free edition of the software. All of our trials are full version. They are full functionality, and they come with full technical support. So when you're using our trials, please don't hesitate. Use our forums. Chat with our help desk professionals. If you need to call them, please go ahead and do so. Our products are the best in the industry, and we're not afraid to stand behind them, even in the free trial editions. So have some fun with them. Learn lots about them. If you have specific questions, go ahead and drop them to me at my Nerdy Like That Twitter tag, and I'll be happy to respond to you. Kind of watching the question and answer pane. We've got about 15 minutes left, it looks like. I am more than happy to hang out here for a few minutes, take question and answers. We can do them live, or if you're interested in just typing them into the Q&A pane, I can take them that way. What I'd like to do is go ahead and we'll pass the hot seat back over to Chris and have him kind of do some finish-up stuff, and I'll watch the Q&A pane for any additional questions. With that, Chris, the floor is yours.
Hey, thanks, Chris. Much appreciated and great presentation. Like you said, we have a bunch of questions in the Q&A for you. So for those of you in the audience, if you have a question for Chris, the other Chris, please feel free to go ahead and ask them. Just use the Ask a Question box on the left-hand side of your console. We have a bunch of questions though already, so I'm going to fire one off to you, Chris. And this one comes from Nick. He's asking, can the initial first backup for replication be done locally, then be seeded at a remote site? How is that best done, do you think?
That's a good question. The answer, first off, is yes. And my preferred way of doing that is to take the backup locally, and I'll make what's called an active full backup. So it's going to actually look at the source files. It'll make the backup of the virtual hard disks as well as the associated configuration, XML, binary, snapshot, or any other files you have associated with that machine. Now, I use Veeam Backup to make that. I have automatic compression already enabled by default. So it'll compress it and dedupe it, and then I drop it onto a removable disk. Now, I happen to use one of those portable hard drive units. I like them. I have one that's 100 gigs in size. I can fit just about any VM on there. I'll put it on that portable hard drive. I'll take that physically with me. So in my case, we happen to have a site that's in Columbus, Ohio, and then another one that's in Cleveland. I'll make the initial backup in Columbus, and then I'll physically drive to Cleveland with my hard drive, copy that backup when I get to Cleveland, and then I use Veeam Backup and Restoration once I'm in Cleveland to restore the backup. And that's important, right? Because I need fully functional virtual machines that are actually running, right? I'm going to be doing injected increments into those virtual machines. I don't want to do a restore when it's time to fail over. I simply want to fail over and have that machine ready to run. So best practice, I like the idea of putting it to physical media and actually physically transferring it. If you're transferring it long distance, I've seen a number of individuals drop it in a FedEx envelope, and that way I've got next day delivery of my Replica seed, and it's ready to go. It's a good way to do it too. So lots of options. More than anything, remember, because we're working with WANs, we're probably trying to avoid that initial workload of WAN traffic. So a Replica seed is a great way to get that done.
Question here for you. This comes from Barry. He's asking, do you need to be concerned with RPO when your entire environment is replicated?
Oh, that's a good question. Do I need to be concerned with RPO when my entire environment is replicated? I think we're always concerned with RPO. RPO is recovery point objectives, remember. And the idea behind recovery point objective is I want to lose the smallest amount of data possible. And generally speaking, RPO is directly related to the frequency that we make backups or add backup increments. So if you'll think about that, even when I do replication, replication is really just a hedge so that I decrease my RPO, right? I'm going to get low RPO by doing that. Now, I'm not going to get 0 RPO. Remember, if I have a 5-minute increment for updates, I'm not going to have 0 RPO unless my environment happens to have 0 changes during that 5-minute time frame. So when you talk about replication and you talk about trying to get to 0 RPO times, Veeam Backup and Replication is not always going to get you to 0 RPO. We generally will say close to 0, and a lot of that depends on the environment that you're working in. There are some tremendously expensive solutions out there in the market today that will promise to get you to 0 RPO and 0 RTO times, but you pay an enormous amount of cost to ensure that that happens. Compared to, with Veeam Backup and Replication, it's just included. It's part of the cost of the software. So is it possible to do better? Absolutely. It costs a lot of money, and frankly speaking, I just don't think in most cases that it's really worth it. So yeah, we always are considering how to get to the lowest RPO possible. Great question.
This question comes from, sorry if I mispronounced their name, but Aaron. This is asking, is the full VM replica a one-time job, or does it work like a synthetic full backup?
Oh, that's a great question. Our initial full replica is a one-time job. So when we make that initial copy, it is a one-time copy of the virtual machine. And then everything else from there on is actually a incremental backup, and we will actually add that increment to make a synthetic full on the target. So if you were to go back and if you were to look at, I think it's the second or third slide when we talk about the basic operations of replication, I used that change block tracking mechanism. I used that as the basis to establish the list of changes that are going to be written to an increment. Once that increment's written, I pass it across my WAN link, and I inject that increment. Synthetic full backup is what we would call it, so that my virtual machine on the target host is always up to date. Now, in this case, it's not a backup because the virtual machine is not a backup file. So it's actually a operational virtual machine. It's not in running mode, but we're going to actually inject that increment into that virtual machine and then create a restore point, that .vrb file. But in answer to the question, it's a great question, Arun. The full VM replica is a one-time job. It runs up front when we create that replica, and it's that job that's going to cause the significant WAN traffic, and it's why we would use Replica Seeding. A super question.
All right, we got a long question here for you, and this comes from John. So I'm going to read it. He sent it in 2 parts. It's a long one. So John's asking, are there any Hyper-V size limitations for Veeam in backup and replication scenarios? And he said he was talking about backing up and replicating multiple 200 to 500 gigabyte VMs across a WAN. Is this too much? With VMs approaching 1 terabyte, is this a problem?
So from a Veeam perspective, we're not so concerned with the size of your virtual machines. From a general overall backup replication perspective, as your virtual machines start to get larger and larger, obviously the concern becomes time. If you're talking about a virtual machine that's approaching a terabyte in size, I'm assuming the reason that it's a terabyte in size is because it's probably hosting a database workload, and that database is constantly changing. If that's the case, when you start talking about replications, not only are we interested in what's going to happen with that initial copy, right? Building that initial replica is going to be significant in terms of size, and if you're going to transfer it across your WAN, that's going to be a significant amount of traffic. But we're also concerned about what's going to happen if you have a database that has significant changes and you're replicating that at a very short interval. Like if you take the minimum 5-minute interval, if you're doing lots and lots of replication across that WAN link, you're going to provide a lot of workload for it. So we think fairly hard about how we want to do replication with those sizable virtual machines. In an environment like that one, I suppose it's technically possible if you have a VM that's at the terabyte size, use a large portable drive, make your initial replica seed, and physically transfer it using the portable drive. But there are a lot of other things to consider there, right? What type of disk storage are you running it from? Would be one that I would go right to immediately. I'm assuming a virtual machine of that size, you're probably doing something specific in terms of storage, maybe SAN or NAS-based storage with it. Those are definitely things that you want to start thinking about beyond just what we would get from the initial replica. So is it possible? Absolutely. Would I do it? I don't know. I'd want to know a little bit more about the environment that we were going to run it in and how that replica was actually going to be hosted, in a little bit more detail about how the updates were going to occur, how much data was going to be transferred. And unfortunately, those are things that you're going to have to do in a lab-style environment to get yourself a proof of concept. Now, since you asked the question, please feel free. Drop me an email. My email address is chris.henley@veeam.com, or use my Twitter tag at NerdyLikeThat. I am more than happy to help you through the process of getting the right resources to do the testing to find out how that would work in your environment. I told you we stand behind our products 110%, and that's something that our systems engineers would probably love to help you with. So great question, and more than happy to help you find a great solution for it.
We had a question here for you. This one was asking, is there a way to test the backups and replicas?
Oh, that's a great question. Now, one of the things that Veeam has become known for is this thing called Sure Backup. And we actually have built it out for the VMware environment. We haven't built it out for the Hyper-V environment yet. Reason being, architecturally speaking, Hyper-V is a very different architecture from VMware, and we're thinking about a better way to validate backups. Now, if you've done backups in the past, you know about checking the box validate backup, which essentially means did it complete successfully. It really doesn't actually validate anything internally. We use this thing called Sure Backup on the VMware side, and what we do is we simply say, let's build out a little lab environment, and then if you want, you can take a backup of a virtual machine that you just made, move it into that lab-style environment, and actually bring it up and run it. That way I know for certainty, if it's, let's say it's strong database workload, I need to know not only that it completed successfully, but that I have all of the data that I expected to get from that backup, that it was quiesced appropriately, and that I have everything necessary to run that VM. And so from a VMware perspective, absolutely, we provide Sure Backup as a method to go in and validate the quality of the backup, not just the completion of the backup. Now, on the Hyper-V side, rather than creating a lab-based environment, what we'll do is you'll simply take your virtual machine and you'll use a called Veeam Explorer tool, and you can actually explore the content of the backup. And that does not require any lab environment to do. You can simply take the backup file, peruse it, actually even recover individual components, pieces out of that file, which is one of the things I just absolutely love about Veeam Backup. If you're running in a Hyper-V or a VMware environment, we run this thing called instant file level recovery, where you can take an existing backup, peruse its contents, and go all the way down to the individual file level and say, gosh, I need to recover, a Word document that I created a week ago. There it is. It happens to be in that backup on a virtual machine. No problem. Take a couple of seconds, search through, find the file, copy the file out, and paste it onto my machine. Or copy that file out, add it to an existing virtual machine that's already running. So yes, you have lots of different options for validating backups. If you're running VMware, use the Sure Backup method. If you're running Hyper-V, use that File Explorer and, of course, the Instant File Level Recovery toolset. Great questions.
We got time for one more question. This one, again, comes from John. And just by the way, for those of you who didn't get your question asked, what I will do is I will supply Chris with your question and your name and your email after the webcast. And I know in the past Chris has loved to get back in touch with people from their questions from the webcast. So if you don't get your question asked now, I'll make sure to ask it, to give it to Chris so he can answer it, over the next couple days or so. So don't worry about that. But the last question here we have before we close out today's webcast, we'll ask this one. This one comes from John again, and he's asking, using SAN and Hyper-V, is there a problem with using cluster shared volumes, and can backup and replicate from a single host in the cluster to another site across WAN?
What a great question. I should pay John for this one. So, one of the things that we really wanted to make certain of when we were working with Veeam Backup and Replication in Hyper-V is that we had the ability not just to do replicas of individual virtual machines. We wanted to be able to make those replicas of cluster shared volumes and their associated components. So yes, there is support for cluster shared volumes in Hyper-V. Using SAN, you have tons of opportunities. So great solution and a great question, John. I really appreciate that. That's one of those home run questions you hope somebody asks so that you can highlight how cool your product really is. Yeah, there is support for clustering in Hyper-V, multi-node, and it works incredibly well.
All right, thank you, Chris, so much for your presentation today and getting to everybody's questions. I really appreciate that. So for Tyler, Nick, Adam, and Helio, I will give Chris your information and your question, and he will definitely get back in touch with you. But thank you all for joining us for today's webcast, Replication Over the WAN, an in-depth guide to Veeam Backup and Replication for disaster recovery, which has been sponsored by Veeam. Big thanks to Chris for joining us in his presentation, and two of us would like to extend a big thank you to everybody for joining us for today's webcast. And hopefully we'll be talking to you all again soon. Thanks, everybody. Have a great day.